Hey everyone, it's TJ with Avidyne. In the following brief video, we're going to be discussing the IFD interface to the Garmin GDL88. As always, nothing in the following video is FAA approved data. This is all for reference use only. For FAA approved data, please refer to the IFD installation manual. Make sure you've got the latest rev. So, before we get into the GDL88 interface, one of the things that we definitely want to make sure we understand is using RS-232 versus RS-422. Okay? Typical RS-232 logic is a positive 5 volts gives you a logic low, a negative 5 volts gives you a logic high. But where that transitions between a logic low and a logic high isn't truly at 0 volts DC. It's actually about 1.5 volts positive. And what that means is that anything on an RS-232 line that measures less than around 1.5 volts is going to be viewed as a logic high. Okay? With RS-422, it uses a transmit receive plus and a transmit receive minus, depending on what end of this thing you're on. So it's a 2-line system rather than just a single line RS-232 transmit to a receive. Okay? And the way that it works is the positive logic line is going to look at a positive 5 volts DC as a logic high, and it's going to look at 0 volts DC as a logic low. On the negative logic line, it flips it. So it looks at a positive 5 volts DC as a logic low and a 0 volts DC as a logic high. So it's important to understand kind of what's going on here. And if you'll notice, if you look at an RS-422 negative line, which is not really even a negative line, it's more of an inverted, it basically has the same logic structure as an RS-232, but instead of going to negative 5 volts, it goes down to 0 volts. So what that allows us to do is that allows us to use an RS-422 transmit inverted line or a transmit negative line to communicate directly with an RS-232 receive, since the logic is basically the same. Now, there are some things to be aware of here. With an RS-232 connection, we would typically be looking at a 10 volt differential, right? Positive 5 and negative 5. So with RS-422, it's going to put out a positive 5 or 0. And since that 1.5 volts mark is where the logic flips, it's important to understand kind of how that works. So ultimately what that means, in my mind, as a troubleshooter anyway, is that using an RS-422 negative output to feed an RS-232 receive input means that I've only got about 1.5 volts of wiggle room there for any type of electrical noise that I might have in the system. So it's very important to make sure that I've got these shielded correctly for this to work without any kind of EMI that might exceed 1.5 volts at any given time. Okay? And if you guys have any questions on this part, feel free to contact me. Contact tech support. We'll be glad to get you some more information on it. But let's go ahead and jump into the GDL88 interface. So with the GDL88 interface, it's important to understand that the IFD is compatible with the GDL88 for ADS-B in only. As of the time of this recording anyway, the IFD is not a certified GPS source for the GDL88. Okay? Now, if you have a GDL88 that has its own GPS built in, and it's got its own connection to its own GPS antenna, it can still be used for ADS-B out all day long, but that has nothing to do with the IFD at that point. The IFD side of this is going to be using this for ADS-B in. Okay? Now, a lot of these aircraft will have a GDL88 installed where we're only using it for an ADS-B in, and they've got an ADS-B out transponder or what have you on board, and that's fine too. Just understand that if we're using the GDL88 to provide ADS-B out, it has to be the version that has its own built-in GPS, because the IFD is not a certified GPS source for the GDL88. Alright? So, if we jump into these drawings here, what we'll see is we've got the IFD providing the ADS-B plus G protocol at a 9600 baud rate, or the ADS-B plus G2 at 38400 baud rates. Even if the GDL88 is only being used for ADS-B in, we still have to give it GPS. Okay? Now, that doesn't mean it's certified ADS-B out GPS, it just means that it's GPS position information. And you'll notice also that the IFD utilizes that RS-422 inverted output, or the negative output, from the GDL88 for ADS-B weather. So, on the IFD end of this, we're going to set that for capstone weather at 38400 baud rate, or capstone high-speed weather at 115-200 baud rate. And that all depends on what baud rate you want to send out from the GDL88. Okay? The IFD can utilize either one, but it's got to be set the same on both ends. So understand that straight capstone is 38400, capstone high speed is 115-200. And the IFD is going to utilize the ARINC 429 connection for GDL88 traffic, and will display on the IFD as legacy TAS symbology. There is not yet an ARINC 429 protocol that allows for full ADS-B symbology. Okay? So, with the GDL88, we will bring that in, we will display the traffic, no problem, but it will be legacy TAS symbology, not the full ADS-B. And you'll notice here also that the GDL88 utilizes the time mark out connection. So you got to wire that guy up as well. It's just a time mark out positive from the IFD to the time mark 1A line on the GDL88. And that pretty much covers this interface. So as always, if you guys have any questions, don't hesitate to contact us in tech support. And thanks for watching. We'll see you in the next one.